So Abhinav will start the session. I'll give the introduction because it's already 6:10. We'll start the session, and I'll give the small introductory part today. People will be joining because links were sent a bit late, so they will be joining. Okay.
Okay.
Okay. Good evening, everybody, and welcome again to the session. So yesterday we had Mr. Abhinav teaching us a session on AI, which was he had gone through introduction and the demo part, and today he'll be continuing the session from yesterday's session. So without and you guys feel free to use the chat box and ask any doubts you're having. He will clarify each and everybody's doubts. So without taking any time, I would like to give this time to Abhinav and start his presentation,
Okay. Shall I share my screen?
please.
Yeah. Okay. So, welcome everybody and good evening. Yeah. So let us begin with the agenda for our second day. So today we'll be looking at trying to go over machine learning with Python. Okay. Specifically, we are going to touch upon TensorFlow, a deep learning library, as I was telling yesterday. And then the second one, after we build a model on Python, we are going to try and look at IBM Cloud. It is another similar cloud platform like Google, but on Google we had done an image processing based project. So here we'll be doing a text based, basically like a personal assistant kind of a chatbot specifically. So we are going to leverage the intelligence of so Watson was one of the first intelligent computers that uh, which was much ahead compared to any other computer when it comes to AI. Basically comes to intelligence. So IBM has actually opened up a API on Watson where we can use a lot of its features from the intelligence to the answering of our queries, the customer queries, those kind of stuff. So we'll try to leverage the IBM Watson API, trying to build a assistant or a chatbot out of it. Okay, so yeah, let us begin with the TensorFlow for today. So the first use case that we'll be looking at is review analysis. So this is actually just as a beginner, I have taken up just to begin into machine learning. I have taken a data set that is already present in TensorFlow library. So TensorFlow is again by Google. So TensorFlow provides us a library called TensorFlow datasets. Okay, so you can import that library, and then you have a number of data sets that come with it. Okay, so we can actually use that for the beginning. So again, as I was telling, for a person who is getting into machine learning for the first time, trying his hands on algorithm, on programming, you don't want him to waste time looking for data sets or searching for the best suited data set. So there are a few inbuilt data sets that already TensorFlow provides us, and today we are going to use one of them. Okay, so in the beginning we have I have imported. Okay, coming to the editor that I'm using. I'm using an editor called Google Colab. Okay, so it is actually it means Google Collaboratory. So it is a collaboratory platform for programming, specifically in Python. So here you are allowed to use certain amount of CPU, GPU, and RAM for free as a part of the research project at Google. So you can go to Google Colab, maybe. Yeah, so collab.research.google.com. When you go to this link, you can open a new notebook, and it will basically open like an empty editor tab where you can continue writing programs and executing. So the one Good thing about Google Colab is, first of all, it is all on the web, on the cloud. So you need not worry about the computation intensive task that we are trying to do. So we are basically trying to run TensorFlow, which actually is, when it comes to certain tasks of deep learning, it is quite CPU and GPU intensive. So Google actually provides us with a few powerful CPUs and GPU pieces for us to work with. So that is one really good thing about Google Colab. And yeah, another thing is, you can share this document with as many people as you want and make them collaborate with this one project at a time. So that is another way it is helpful. And usually for my demos, I use Google Colab because it serves as an easier way to execute code pieces part by part to show how it works. Okay, so that it is better for you also to understand in that way. Okay, so here you can see, uh, I'll okay. So I'll open a new notebook. Okay, then you can give a name to our notebook. I'll call it REVANA, review analysis. Okay, so now first thing you need to do is connect it to a runtime. So runtime is basically like basically you're connecting to the Google server so that you can start using their resources. So I'll just click on connect, and then it takes some time. Okay, so once it has connected, you can go ahead and start writing code. Okay, so this is not only a code editor, you can also add text cells if you want to explain what you're trying to do. I will say this is a TensorFlow based program or model. So this is just a text editor kind of a thing where you can display stuff, so that when you share this, when you share the document or when you share this notebook with anybody else, it is better at understanding rather than having comments in the program. Okay, so let us begin. First thing we'll need to do is import libraries. Okay, so first thing, yeah, importing libraries, because there are a number of libraries that we need to install usually for all Python programs. Okay, so in this case, it's going to be TensorFlow. So I have TensorFlow and one of its related library, TensorFlow Hub, and then I have TensorFlow dataset for the dataset collection part, for loading the dataset. Okay, then as I press Shift Enter, the code gets executed and it goes to the next uh, whatever is below it. So here it's a text, so it has got highlighted. So I don't want it now, I'll just delete it. And now you can see, if I'm at the last of the notebook, it is going to open up a new code cell for me. Now I can write a new piece of code which is going to be in the same runtime. So the whole program is connected, and it is not like separate programs how you would be doing on either command prompt or on Visual Studio or some other offline editor. So Visual Studio, things like that, they expect you to write the entire program at a time, like how I've done here, and then execute it as a whole. Okay, though there are ways to run selections or line by line, it is usually much easier to run it on a platform like Google Colab, where you can write one piece and then Shift Enter, you execute that piece, and then you go to a new code, and then I can write a new piece of program. So I'll just say hello now, and you see it gets keep executing. So it is within the same runtime, unless I go to runtime and say restart runtime. When I click on restart, it is basically starting everything from ground zero. So I basically have to re-execute each program for the variable, storing the variable of analyzing whatever I was trying to do throughout the program. Okay, so just because I have restarted, I'll just re-execute. Okay, now second part. Second part is going to be loading our data. Okay, so we need to load our data from the TensorFlow dataset library. and we specifically need two data sets, one for training, one for testing. Okay, so that is the you have this TFDS. TFDS is basically TensorFlow dataset library name. Okay, so you have TFDS. So you are basically loading that data, loading datasets from that library. And which dataset do you want? I want the dataset which has the name IMDb reviews. So that is basically movie reviews which you are trying to classify between positive and negative. And then you're going to I want to split it, as I told, into split train and test. So I want it to split into train and test so that I can have separate two different data sets. And then also, as I was telling yesterday, we are trying to do it in a supervised learning format. So we are going to give input along with the label so that it can remember how to match this particular value to the label. So we want the data set to be in the supervised learning format because you want the data and its label. So here it is going to be some review, the sample review, along with whether it is positive or negative. So you're going to take it as a supervised in a supervised format. So then we can execute. So now it is going to download our dataset onto the runtime. So now if I go and restart the runtime, I need to re-download the dataset because it is wiped out of my RAM or out of my current runtime. Okay, so let us wait for this to download. And then after the training data, we'll just look at how the we will see what the data consists of. This is downloading. In that time, I can just say okay. So, dataset IMDb reviews downloaded and prepared. So it is ready for us to use it now. So I can just uh, execute a part where yeah. So this is going to tell us what is present in the dataset. So there is a TensorFlow string kind of a data as first part and integer data in the second part of the data set. When I say train data, uh, anyway, so we will look at so data is usually in the format of a review, a string review. That is what people have given as a review to one particular movie, followed by whether that particular movie is a review is a positive or a negative review. So these are the input data that we are trying to give. Okay, so after that. Uh, okay, coming to another aspect of trying to decode text. So the first thing we need to do while trying to understand text is put it into some readable format. So we usually have languages to read from. So we are going to put up our emotions or our thoughts in form of some language. But for the machine learning model to understand what is the emotion or what is being portrayed, it needs to be converted into some kind of a numerical format. Okay, so conversion of text into number may be as simple as converting the individual characters into the ASCII values or into its binary directly. But when it comes to these kind of deep learning problems where we have emotions or some kind of a thoughts attached to it, we can't just have this dumb conversion rule. So we need to have something more. Uh, it is converting based on some other format. Okay, so we are not going to take the headache of trying to convert the text into numbers. There is already a Google has already have had a trained model. Okay, so I'm going to take it up as a pre-trained model as a variable from this particular link. So there is the TF hub, so TensorFlow hub. From TensorFlow hub, so there is one particular algorithm that I'm going to take and then add it to a variable called hub layer. Okay, so a neural network, as I was showing yesterday, is basically a few nodes connected to a few more nodes in the next layer, which is in turn connected to the succeeding layers till you have that one final output node. So the first layer here, or the first set of nodes, is going to be this hub layer, which is going to, it is going to be a Keras layer. So Keras is a subdivision of TensorFlow that helps us with a deep learning problem. Okay, so basically to help us with deep learning, they have something called Keras. So I am going to say I want a Keras layer, and that layer is going to be the pre-trained model, that is converting the text into some kind of a number for us to work with. Okay, and then I say the data type is going to be string, and it has to be a trainable data. So the input is going to be string, so it is going to be tf.string. If you remember when I had executed this, the first one, trained data, you can see here the data is in type of tf.string. So that same input I am giving into the model. So because that is what I want in the input. So I am informing the hub layer, telling the data type, D type will be string. And then I'm setting it to trainable, because it is not a trained mod. Okay, I named it pre-trained model, but it is just a model. So it is just a network that is there. We have to train it when it goes on. So trainable equal to true is what I set. Okay, I'll just execute it. Okay, yeah, so that we have it executed. Okay, now after having the numerical format of the review, what we need to do is now go on with the computation to understand whether it is a positive or negative. So we are going to basically build the neural network. Okay, so I'll just give a variable name model equal to tf_keras.sequential. So basically, I want a sequential neural network, that is one after the other. So there is no kind of random networks or out of order network. So I'm going to have a sequential neural network, one after the other, and that is going to be a TensorFlow Keras based neural network. So I set a model to that particular kind of network that I want, and then I'm going to add the hub layer to it. Okay, the hub layer that we just created above. Okay, the model that is going to convert text to number. So I am adding that layer to the model. So it is similar to how to make a multi-layered cake, you are going to bake individual cakes or slices of cakes, then stack them one on top of the other. So this is basically, hub layer is one slice of cake that we have built, and this model is the complete multi-layered cake. So I'm just going to add one layer, that is the hub layer. Then I add another layer that is going to do a few calculations. That is going to be a rectified linear unit function based activation neural network. So that is going to take the number that we had given from the previous layer and do a certain kind of calculation, which is going to convert it into a set of probabilities for either it is a positive review or a negative review. So the machine learning is always not sure uh, whether it is obviously positive or obviously negative. So it is going to give out a percentage of what it thinks can be positive or negative, like maybe 60-40 or 90-10, 97-3%, something like that. So that is what is going to get outputted from this second layer that we have added. That is the center, the hidden layer. Then you have the third layer that we are going to add. Okay, so this is the third slice of the cake that we are adding. tf.keras.layers. So another layer. This is also a dense layer. So basically it means I'm connecting all of the neurons on this layer to all the neurons on the previous layer. So there is complete interconnection. It is not that only few are connected and few are left open. So a dense layer means all are connected together with the previous layer. And here there is only one node because we have only two classes output, that is positive and negative. So we want only one output. If it is nearer to zero, because I have used an activation function called sigmoid. The sigmoid is basically kind of that summation. So it sums up all the probabilities from the previous ReLU layer, and it gives spits out a number that is between 0 and 1. So the nearer to 0 it is, the more negative review it is, and the more positive it is. So that is what is going to be the output of this third layer. Okay, and then I want to give out a summary of whatever we have built. So whatever I have told you, that layer 1, layer 2, layer 3, I basically want the 3 flavors of the cake slices I have put. What is it doing and what exactly it is. So just say model.summary, so that it's going to give out that data. And then coming to the actual model part, I say model.compile. So basically it is kind of putting the icing over the 3 layers so that I make it a complete cake now. Model.compile optimizer. Okay, yeah, now coming to the optimizing and loss function part. Okay, so usually when machine learning model is trained, it is trained on one particular uh, as and when it trains, there is going to be loss, or there is going to be wrong prediction. So a review that says this was a amazing movie might be classified as negative. Okay, but because you have already given the label saying it is a positive review, the model is going to check. I have told it is negative, but the user has told the data is actually positive. So it means this is a loss for me. I have done a wrong calculation. Okay, so that is a loss, and the optimizer is a function that is used to reduce loss. So there is this Adam optimizer that we have used for the this particular use case, and then loss function is binary cross entropy. So we have used the binary cross entropy because we have two data classes, that is binary. So bi basically means two. We have either positive review or negative review. So that is the reason we have used the loss function to be binary cross entropy. And then I have just told the model, whenever you're training, I want only the accuracy metric. I don't want anything else to be printed out. Okay, so what are the metrics I want to get printed? Because if you usually see in the speedometer or on the dashboard of the car, whenever you drive, you see a lot of metrics, from the fuel percentage, temperature, to the RPM, to the engine speed, wheel speed, or the vehicle speed. So here, the same kind of metrics, I want only one metric, that is the accuracy. Okay, so now we'll execute it. See, so now you can see it has given the summary of the model. So there is layer type, output shape, and number of parameters. So the first one is the Keras layer. That is the first hub layer that I was talking about, which is going to have 400,000 parameters input. That is going to be the text based character input that we are giving. Second is the dense layer. That means it is connected to all the previous nodes. Okay, so here there are 16 nodes, and then last layer, the output layer, is going to be with one node. So you can see here this number 1. That means there is only one node that is going to give out either positive, or rather it's going to give a number between 0 and 1. Okay, so yeah, that is our model ready to train. So now we will train model. So training the model is going to be as easy as just saying model.fit. Okay, so there is this train data that we take. We are going to shuffle it because we don't want it to be in order. Maybe the data set has it in order, like the first 1,000 are going to be positive and the next 1,000 is negative, something like that. So we don't want that discrepancy to pass on to the neural network. So I will have it shuffled so that it is in random order in batches of 512. Okay, and then I'm going to have 20 epochs. So 20 epoch is basically number of iterations you want the new network to train so that it becomes more accurate. Okay, so it can this is basically all the result of trial and error. So there's no hard and fast rule that for this data there has to be so many epoch. Okay, so there are some cases like in the KNN model, the k nearest neighbor classification model, where they say that k value of the model has to be equal to or most probably will be equal to the root of the number of total elements. So for example, if there were 400 or 4,000 elements, or say 400 elements, there has to be, the k value has to be 20. So there is no hard and fast rule like that for epoch. Okay, for that matter, there was no hard and fast rule for k value as well. So it is basically you find the optimum value for your model for your kind of data. So for the sake of time, I'll let it remain 10 for now. Okay, so we might see a problem in accuracy, but that would be enough to prove the point for now. And then I have validation data again in the batch of 512, and then verbose. So verbose is again like how we have metrics. So metric is again how much data you want output. So the same way, verbose is nothing but how much information you want out of the model when training. Okay, so we'll just execute it and we'll see how it happens. Okay, so you see whatever this data is coming, this is part of verbose equal to 1. So that minimum data that we want. Okay, so you can see now Apache 1 has started trained 49 reviews, and it has got about 64.9% accuracy. Okay, because this I have put 10 Apache, this is going to be quick. Okay, and just as a just to give you an analogy why I am using Google Colab. So as I told, these give us pretty powerful CPUs and GPUs. Okay, when I try executing the same program on my laptop, which still has a discrete graphics, but it takes 10 seconds to train the same Apache of 49 reviews. So here it is taking 5 seconds, 112 milliseconds. So that is almost half the time. So in that way, even the training is happening faster. Okay, yeah, so now we have completed 10 of 10 Apache training. Okay, and there has been 90.3% accuracy. So 0.903 is 90.3% accuracy. So that is pretty good for us. Okay. Okay, so now we have our model trained. Okay, so these are the verbose thing that it has spitted out for us to see how the model has been training. Okay, so if you want more information, you can change it to 2 or maybe 3 also. Okay, and then you can also change the few parameters that you can change to increase or decrease accuracy is the batch size and the epoch size. Okay, so if you increase the epoch, the accuracy will increase, but it is going to increase in the time of the training, because that is basically how many iterations you want the model to train. Okay, so now the next part is going to be taking a prediction. Okay, so let us I'll open another code cell. Yeah, and now I'll say I'll take a variable prediction equal to, I'll say model dot predict. Okay, so basically I have this model that has been trained, and I use that model. So there is a function called predict. Okay, where I give an input of something and it passes on to the model to predict the output for it. Okay, so yeah, so we'll give in an input. So here I open a square bracket because the model, the prediction part expects it to be in the form of a list, not in the form of a single element. So lists are basically a set of elements. Okay, here I'm going to have only one element in the set, but it expects a list. So I'm putting a square bracket. That means it is present within a set. So here I can give any number of reviews. So I'll just put number for now to show review 1. This is going to be review 2, and then review 3. Okay, so for review 1, I will say very good movie. Okay, the second review will be okay, we'll let it remain one more review for now. Okay, and then I execute it. So now it has predicted and put the prediction in this variable prediction, prediction. Now let me print it. Okay, so I'll print the prediction, and you can see the value has been 0.8606. So that is basically 86.06%. Sorry, that's not a percentage. 0.86 is nearer to 1. So that basically means that review that I have given, that very good movie review, is a positive review. Okay, so basically here we have trained a model and we are testing it. So this very good movie review has not been seen by the model. I have given a random input from whatever I have tested, and then you see here it has come out. The review has come. Okay. Then I take another test case. I just say print model.predict. It was very good. Okay. So here you see the value is going to be 0.846. So that is again nearer to 1. Okay, basically round off. So it is nearer to 1. So it is a positive review. Okay, so now let me just change the review to terrific. Okay, so here it has given a answer of 0.37. So that is one problem that you have seen in our model. So terrific either can be good or bad. Okay, usually when people say here I am meaning it to be good, but the model is thinking it is bad because it has not had enough examples of such reviews. Okay, so it is thinking it is a negative review. Okay, but what if I give an actual negative review saying horrible movie, or let's say boring movie? So these are two elements that I have given. So this is one of the set. This is the second of the set review. So it is going to do perform individual prediction for both and give us two different values. So first one is 0.11. That is again nearer to 0. So it is a negative review. Second one is 0.17. Again a negative review. Okay. So yeah. So another way of executing maybe can be you can either build a graphical user interface in Python or build some HTML website and put this code to be the backend. So you take a text field, take the input whenever the button is clicked, take the data from the text field, pass it on to this prediction model, and it is going to give out a prediction that you print it onto a label or some kind of a text box. Okay, so here I put it up in a for loop. Okay, so this is going to take an input, enter a review to predict. So I can say, so I basically made this loop run for 5 times. So 5 times it is going to ask what, enter a review. I'll give 5 reviews. Okay, so now you can see the first great was 0.98 positive, bad was 0.13 negative, amazing 0.99 positive, boring was negative, and not good was, you see, now this, if you are able to analyze, there is this word good in it. So because of that, it has got confused. So it is not able to understand the context not good as together. So it has seen not and thinking maybe it is negative. Then it saw good, maybe it is positive. That is the reason it has come out to be closer to half. It is not very close to 0, but still it is less than half. So it is a negative review. Okay, yeah. So that is this model. Okay, so I actually have another model not on TensorFlow, but this is another machine learning based model. So here there is no neural network. So this is based on the SciKit learn library. So the previous one was based on TensorFlow, and this is based on the SciKit learn. So another popular framework for beginning with machine learning. Okay, so first again I'm importing all the important libraries. Okay, yeah, so this is connecting to the runtime. Okay, and then it executes. Yeah, then I'm going to import the data set. So this is basically I'm trying to build a model for predicting diabetes. Okay, so I have a downloaded, so this is kind of a bit advanced because you need to search for a data set. So as I was telling, there is a website called Kaggle. Okay, so there is a website called Kaggle where you can search data sets, and it is actually a very good way to get your data set. Okay, so yeah, I have taken this dataset from Kaggle, and I have downloaded it as a CSV file. Okay, so I have it in. Oh, okay. Okay. So I'll choose file. It's there on my desktop, the CSV file. Okay, so that is getting loaded, uploaded onto the Google, the runtime that I'm using. And once that is done, yeah, once that is done, it is okay. It has been saved onto the runtime. So you can go ahead with reading the library and start working on it. Okay, so the first thing you're going to do is initialize data and print number of data elements. So just to see how it is. Okay, so I'm putting it into the text variable data set. So there are 799 entries there. Okay, and I just basically have a set of instruction that is going to remove the zeros, because there are some in the Kaggle data set, there are few values of few people's glucose value, blood pressure value, BMI, all these values are zero. So that basically means it was not measured or it was not found for that particular entry. But that actually, if it is actually zero in a human, that means the person is dead. Okay, so we don't want that problem to be in the machine learning model. So we are going to take perform some calculation which is going to eliminate all the zeros. So how does it do? It is going to replace zeros with some. It is going to replace zero with nothing. So zero is some value. Okay, the value is zero, but I want to remove zero and make it nothing. So it is a null value there, and then I take a mean of the data set, skipping all the null values, because I want to take the mean of all the 800 or 799 elements except the ones with the zeros that is not given. So I'm basically replacing the zeros with the mean in their particular value, so that if not for the accurate data, at least have some kind of average data there to train on. Okay, so basically this has eliminated zeros. Okay, I execute this, and then I split the data into training and testing data set. Okay, so X is going to be the all the all the features of the person, like the things you see here: glucose, blood pressure, skin thickness. So there are a lot of them, 7 or 8 of them. So all of these are going to be part of the X of the data, that is the input, and Y is going to be the output, that is whether it's diabetic or non-diabetic. Okay, and then I split it into the train and test set, and I scale the data, because usually if you just if you're able to see this, glucose values or blood pressure values, they're all not they don't have a specific range. So they can be as low as 70, 80, 90, or they can be as high as 200 also. So we don't want to have such a huge range in data for the model, because it's going to become again computationally intensive as well as take a lot of time. So I scale the entire data within -1 to 1. So all the decimals, so -1.0000 to 1.00. So this is going to scale all of the data so that it is there within a smaller range, so that it is better for the model to train. Okay, so this thing is basically the 3 lines that you see here are doing that thing. It is going to take a standard scaler which is going to scale, and then scale the X, and then scale the test set, the train and test set with the same transformation. Okay, so let me go ahead and execute. Yeah. Now we need to, yeah, so here we are going to do a KNN based model, that is K nearest neighbor. Okay, so basically what it means is, if a person's features are nearer to a diabetic person's feature, it means he is going to be diabetic, or he might have diabetes, or he might be diagnosed with diabetes. Okay, second kind will be where a person's features are similar to a non-diabetic person. So that is basically you are seeing how near it is to the actual data set. Okay, so that is why we are trying to use a KNN model or K nearest neighbor. Okay, so based on what we are trying to achieve, we use our algorithm. So this is one best example where we are trying to use the algorithm best suited. So for that matter, we can use almost any algorithm here. We can we can use a deep learning model, or we can use a linear model, anything. But specifically because we are trying to find out how near it is to the specific class, we are going to use a K nearest neighbor. Okay, so let me go ahead and yeah, okay, just give me 1 minute. Okay, I'm sorry, but yeah, so okay, we have defined a K nearest neighbor algorithm. Okay, so here again, I was telling there are 800 values here, and the K value is going to be approximately root of 800. Okay, or specifically because we have split the data into test and train, the training set is going to be around 620, 630. Okay, based on the 80%, 20% splitting rate. Okay, so for that 620 root around 25, 23 is what I have put. And specifically another thing we need to look after is K value has to be odd. Okay, because the K value is basically how many neighbors do you want to check with, okay, to know what you are or what that particular point is. So if you have even number of K, there is a chance that there will be equal number of class 1, equal number of class 2. So that is going to put confusion, okay, for the model to train. So we put it as an odd number so that one of them will be definitely larger than the other set of distance or the nearness, so that we can split it up easily. Okay, so K value 25, and I say K nearest neighbor with the number of neighbors as K, and then there are two classes, that is diabetic, non-diabetic. So P equal to 2, and then here metric is going to be Euclidean. So Euclidean is, you must have heard in the mathematics, the graphing part, Euclidean distance. So that is basically the raw distance between 2 points on a graph. So that is what you are trying to see here. If you, for example, if you graph a just 1 minute. Okay, so I am just okay. So yeah, here you can see I just have a graph of the K nearest neighbor kind of a thing. So here there is just a graph consisting of two classes. All these red ones are class 1, and all of these green ones are class 2. So when you see this one particular point that I'm looking at, you see the K value is 25 in our case. Okay, so I am going to look at 25 neighbors of these this particular point. So I'll just draw. Okay, if you take this red line that I have drawn for this particular point that I have circled here, I am taking 6 neighbors. So in the 6 neighbors, 4 of them are green, 2 are red. So it means that particular point is, it is more nearer to green. So that is nearer in the sense the Euclidean raw distance. Okay, this number of centimeters or number of meters between the graphing points. So that is what is the nearest 6 or nearest K number of neighbors that we take. to estimate which class the model is or the data point is. Okay, so that is the metric that I given Euclidean, and then I train it. The classifier that fit with the training data and the training labels. Okay, yeah. So here we have it. Okay, so this is a quick one. This is not a deep learning model, so there is no that iterative thing happening. So now basically the model has been trained. Okay, so I just uh, give a prediction base a prediction command. So here I'm taking the data set, the test set, okay, the X test, and I'm passing on to classifier that predict. Okay, and then I will also print Y test. Okay, so Y test is actually the actual labels of the X test set of data set. Okay, so Y predict PRED is the predicted uh, value. Okay, so here 0 or 1 means diabetic or non-diabetic. Okay, so basically a 0 means non-diabetic and a 1 means diabetic person. Okay, so here these are all the predictions. So there are around, I see 30, 40 or whatever number of elements in X test. They are all going into the prediction, and it is getting predicted to be all of these. Okay, so when I give only one data, that is the second element, I will see on. Yeah, so here I have given him the prediction model only one data point, that is X test of 2, that is the second element of the test data set. So it is told to be non-diabetic. Okay, so here you may not be able to see the test set data. So we will look at another example where I have the data open. Okay, so here basically these are all the different metrics from, okay, 74 might be the pulse. Okay, 68 was the blood pressure, age was 28. Okay, and then 45 was maybe blood glucose level. Okay, things like that. So there are a number of parameters that I have given input. So this is one person's metrics, or one person's uh, values, the medical report. Okay, so I then transform it, because if you remember I had put up everything into, yeah, I put everything into -1 to 1. So I have to do the same thing to the new data also. So I'm doing the same thing, X dot transform, and then put it into the predictor. Okay, so now if you see, this person says this has no diabetes. So no diabetes is predicted for this particular set of the body values. Okay, now if you see the second part, okay, this second, where his I guess the pulse is 92 and blood sugar is 62. Okay, and I think whatever maybe the metrics, there are, if you see, there are slightly different from whatever is here up. Okay, so because they are different, it has been predicted as diabetes predicted. So it is a diabetic, maybe diagnosed with diabetes. Okay, so yeah, so that is another model that we have seen. So this is a KNN machine learning model, K nearest neighbor. Okay, using the SciKit learn or sklearn library. And the previous one was a deep learning neural network based model in TensorFlow. Okay, yeah. Maybe if you have any doubts, or you have anything to ask regarding this, please put it up. Okay, maybe 2 minutes and we will move on to the IBM cloud. Okay, so I see there are no doubts. So I'll move on to the IBM cloud demo. Okay, so yeah, so IBM is another tech giant that is providing cloud services. And here, similar to Google, so here there is a free tier. Okay, in Google Cloud, you were given $300 in credit to use as much as you want, up to 3 months. Okay, as long as you want, up to 3 months. But in IBM Cloud, there are, with certain limitations, you are given everything. Okay, for example, you may be allowed to run only one service or one instance of one particular service at a time. Okay, in your free or light account. Okay, then you upgrade and you give in your bank details here, then you can start using the full potential of Google IBM Cloud. Okay, so first thing you need to do is register, and this also takes quite some time. Okay, they again have to manually, because these are all cloud services are kind of uh, not still freely accessible to everyone. Okay, you need to create account, they need to authenticate you, and that is when you are allowed to start using it. Okay, so once you create your account, this is going to be a dashboard. Okay, so at the beginning you'll have 0 resources. Okay, I have 9 because I have a few apps services running. Okay, so there is one. If you just look at my resource summary, what all I have been using. Uh, Under services, there is uh, tone analyzer, there is visual recognition, similar to what we have done in Google. Then there is Watson Studio, and there is some machine learning. So all of these things are services that provided by Google, IBM. I am trying to use. Okay, I have put some kind of data, something into it, and trying to build something out of it. Okay, then under storage also there is some cloud storage service that I have taken up. Okay, so now for our what we are trying to build is, okay, let us take a use case saying we are trying to order some kind of a food. Okay, where you usually either you have a app, or when you call that shop receptionist or someone, he manually there's a human there who answers you and who takes your order and all of that. So let us try automating that in an intelligent way. Okay, so for that, as I was telling about Watson is one of the AI and machine learning based intelligent assistant similar to Google and Siri, but it is not available as an app anywhere. So it is available as an API on the IBM cloud. So we are going to go create a resource of Watson Assistant. Okay, so Watson Assistant is, as you can, yeah, about Watson Assistant lets you build conversational interfaces into any application, device, or channel. Okay, so for it is again, as I was showing you Google Cloud. Okay, I guess I forgot to show you one thing in Google Cloud yesterday. So once we have the model trained, okay, once you have the model trained, you actually have, they provide you with a Python piece of program, kind of a which includes the libraries and stuff, so that you can actually put it up as your own standalone solution. So you can ask for predictions through it. It is not deployed, but okay, it is not here. But okay, if you remember from yesterday's video, there was this Python symbol here at the bottom. So that basically, when you click that, it is going to give you a way to use this model that you have trained. Okay, so that is something we are not done. We have only done the core machine learning part. Okay, same thing we are going to do here. We are only going to build a conversational AI, and we are not going to port it into any application or build a complete application out of it. I'm only going to show you how to leverage Watson Assistant to build a AI powered chatbot. Okay, so let us go to create, and here, so you can see here the pricing plan. So light plan is that free plan where you have 10,000 messages per month, and all of the AI based, all of these few metrics. And then light plan services deleted after 30 days of inactivity. Okay, so this is free. And then as you want more, maybe if you're running some commercial model where a lot of people are continuously interacting, or in a real case, Ola, Uber, or some Zomato kind of a thing where people are continuously calling, you need more. So then you can keep going with, uh, you can go on for more. So here there is a plus trial that is for exactly 30 days where you can use more, but it is limited with time. So this light plan is not limited with time. So you can use it for as long as you want with minimum functionality or limited functionality. So I'll click on create, blue button here, and once you click that, it is going to create a service and open it for you. Okay, so this is a new service here. So now if I go to dashboard, you can see there are 10 resources now. So there were 9, now it is a 10th resource that I have used. That is the Watson Studio, Watson Assistant. Okay, so I open that back. Okay, and the first thing you need to do is launch your Watson Assistant. Okay, so here you can see this API key. Okay, so with this API key, you can write Python program or some kind of a application program which sends the text or sends some voice or text based input into the assistant to get an output for the conversational part. So only this core AI based part happens in this Watson Assistant. Everything else you have to build, from the user interface to presenting the data in a nice way and all of those. And in case there is some kind of payment involved, the payment gateways, all of that you have to take care. So here only there is this Watson Assistant is just a conversational AI, a artificial intelligence engine or a machine learning engine that specializes in understanding your natural language. Okay, so let us launch Watson Assistant. Okay, yeah. So there can be a number of assistants under the Watson Assistant service. So the service is one kind of something like a bag. In the bag, you can put a number of things. Okay, so you can build number of assistants. One for maybe only related to banking, one related to food ordering, so things like that. So I have this one assistant called my first assistant. Okay, and then here okay, so you just click on the second button here where you add the skills. Okay, so when I open the first skill, that is where that particular my first assistant has this skill. What is this skill? Of understanding and trying to interact with the person when ordering food. Okay, yeah, okay, now coming back to just let us come out out of machine learning for a while. Okay, so when it comes to talking, or when it comes to conversing, there are three main things that happen. Okay, so there is one, uh, obviously the person talks, but you try to understand the intent of the talking. Okay, you try to understand the intention behind what is being said. Okay, so if I say I want to order pizza, it does not mean he wants to pay his bill. He wants to mean he wants to add a pizza into his cart. So that is that intention that you try to understand. So that is what is intent in IBM Watson. Then there is entities. Entity is nothing but a noun. Okay, so when I say I want to order pizza, ordering is the intent. And what do you want to order? The pizza or burger or pasta or coke? That is going to be the entity. Okay, so nouns are keywords. And then you have dialogue. So dialogue is nothing but the reply that you want to give. So here the first default dialogue, welcome. Okay, so if the assistant starts, it is going to give a dialogue saying, hello, how can I help you? Okay, so let us start building the assistant. I'll say create intent, and I'll name the first one greeting. Okay, name your intent to match a customer question or goal. So customer may be trying to greet the assistant. So I'll say name my intent called greeting, create intent. Okay, now comes the data set part. Okay, so if you remember, we gave 800 values to the KNN model to train. In the same way, for this assistant to train, we need to give values. But the only one difference is the Watson assistant is already trained on text. Okay, so it only has to understand what is the emotion or what is the thought you're trying to convey. So for that, it does not need thousands of data values. You can only give a few. So say hello. Okay, you can say hi. How do people greet? So examples of greeting: hello, hi there. Okay, hey. So I just given 4 values. Okay, so these are the 4 user examples that I have added. So this limited number, it may not be equal, may not be very accurate, but for now it is enough. Okay, so yeah, I have added 4 examples of the greeting intention. Okay, so let me go back and then create another intent saying order. Okay, so second intent will be you want to order something. So how does the user say he wants to order something? He can either say I want to order, or he can say I want to place an order. Okay, or please order me this. Okay, so just few examples. Okay, or add this in my cart. So we have to make sure the examples that you give are not biased, first thing, and second thing, they're not confused with another intent. So if I give a same high order thing, this is going to be both in greeting and ordering. So this thing will get confused. So there is going to be less accuracy here. So such examples should not be given. Purely related to order, 4 examples I have given now. And then another intent, say payment. Maybe he has completed eating and he wants to pay. Okay, yeah, I say create intent. Here, how does a person ask to pay? He will not say I want to pay. Okay, though he might say, but usually he says uh, give me my bill. Yeah, give me my bill, and then what's the total? Okay, or he may outright ask I want to pay. Okay, and then we'll give another saying how can I pay. Okay, so 4 examples for user's intention of payment. Okay, so we have 3 intents. So usually this is what happens. He greets, then he orders, and then he pays. Okay, so now we'll come to entities. Okay, entity is what you are trying to, the noun part. So let us say in our menu we have 2 things. One is pizza, okay, and another is let's say Coke. Okay, so value is going to be pizza. The first one was the name of the entity. Second one is the value of the entity. Okay, so value can be pizza, or I can say veg pizza, or okay, so these are few uh, values of the entity. So whenever a person says pizza, veg pizza, or cheese pizza, it means he's trying to order a pizza. Okay, so this is very rudimentary. This is not a very accurate or not complete market ready. So just to show you the concept is what I'm trying to build. So that is the reason I've not gone into specific details. Otherwise, for each menu item, you need to create an entity because each of them are separate entities. Okay, I'll create another entity saying, let's make it burger. Okay, maybe burger, again veg burger or grill burger, something like that. Okay, yeah, so there are two entities now. Now coming to dialogue. So dialogue is what reply you want the Watson assistant to give. So there is one already predefined welcome. So as soon as the assistant starts, it will give you a welcome sign. Okay, and as you are building the assistant, you can always try it out here. So there is this try it button. When you click on try it, it is going to open the assistant. Watson is still in training. So whatever data I have given, it is still training, and results in the tryout panel may not reflect the latest edit. Okay, so here you see as soon as the Watson has opened up, hello, how can I help you? That is this, the same thing over here. Okay, so I'll just close it now. Anyway, I'll close it, and then I will add a node. What will be the node? Okay, the node is going to be user greeting. Okay, yeah. So what is the condition? Okay, if the assistant recognizes a greeting intention, that is when it has to react with a greeting dialog. So I'll say if assistant recognizes hashtag greeting, so that is a greeting intent. Okay, so if you just realize here, we have intent is a hashtag and @ is an entity. Okay, so we can directly type here hashtag greeting. Okay, so greeting is a entity, intent that has been recognized. What do you want to do? So if he has told hi, the assistant had to give back reply. So I can say hi one, or I can say hello dear customer, or how can I help you? So these are the few replies it can give. And again, these are set to sequential. So it is going to be in order. So every time user greets, first hi will be there. Second time he greets, it will be hello. Third time, how can I help you? Again, fourth time, hi. So if you want it to random, you can set it to random here. Okay, yeah, so that is done. So that is one node that we have trained. So now you can try it out. And I just say hello. It has recognized as a hashtag. It has recognized as a hashtag greeting or a greeting intent, and it has replied with me with one of the replies which I have given. Hello, dear customer. I re-say hi. It again recognizes as a greeting and says, how can I help you? Now, if I say I want to order, it is going to reply hashtag order. So it has understood that it is an order according to what we have put up in the intent. Okay, but it is not giving any reply. It says I didn't understand. Okay, because it is under this anything else node. Okay, if anything else happens by the assistant, then put up I didn't understand, or can you reword, or I didn't get your meaning, because I don't have a dialogue set. So I'll add a node, and that is going to be order stuff. Okay, if the assistant recognizes intent of order, then you can do this wait for reply. Okay, I'll just put what do you want to order. Okay, I'll just let it to remain one now, only one answer, and then Watson can either wait for reply or go to some other point. So let it remain wait for reply. But under this, after ordering, what will the user do? He will want to order specific thing. Okay, so when the assistant asks what do you want to order, he is going to give some value or some entity that we have set. So we're going to add a child node to that node, and if it recognizes burger, it says Okay, I have added burger to your cart. Okay, so this is the reply that I'm going to give. Okay, I can give in a name, order. Okay, and then I will to this node I will add another child node for the pizza part. Okay, order. Okay, so for pizza, what I need to do, I have put a cart. Okay, I said okay, I have put a pizza in your cart. Okay, that completes, and then you have payment. So you're going to add another node for user pays, I call it. Okay, so intent payment. Okay, so if it recognizes payment, how would you like to pay? Oh, how so it will ask how do you like to pay? Okay, so there are, I've given two values, set it to random, and then yeah, here you can again add child node and ask whether if he is going to pay through card, please give your card, or if he pays through Paytm, you show the QR code, or if he pays through cash, giving out the correct change, those sort of things. You can develop it from here. Okay, so there it is. We have basically completed a minimal assistant training. Okay, I'll clear. Hopefully, yeah, it has completed training. Okay, so one thing I want to tell you must have you must have seen how hard it is, or rather how long it will be taking to train a model. Okay, that is because you need to the Watson doesn't know that you are going to use him for or use it for ordering pizza or ordering food. Okay, so the best you can do is, or the best it can do is train from whatever minimum data you are given, because it is already trained at understanding conversation. So Watson is not a ground up machine learning algorithm. It is a machine learning model that is a conversational AI, or a natural language processing model. Okay, so the main intent is it is able to understand. So you are not telling every single statement what is its intent. We have only given few examples of what intention can be there, and from then on it keeps building. Okay, so for example, if I say, can I order and pay? So for example, I've just given something. Okay, here it has taken as order. Okay, by chance, if I don't mean order, or I mean, sorry, it has taken as pay. If I don't mean pay, I want to take it as order, I can go click order. Okay, intent correction submitted, model will be updated. So this is what is reinforcement learning. I am reinforcing the model as time goes on. Okay, so basically we have seen supervised learning yesterday, we had seen deep learning today in Google Cloud, we have seen reinforcement learning here, and actually KNN should have been one of the unsupervised learning format, but I did turn it into a supervised learning by giving the labels. Okay, so it is still as easy to just ask it to split it into two sets, one resembling diabetes, one resembling non-diabetes, and calling it a non unsupervised learning model. But just for the sake of this session and for making it easier for the model and the time, I just put it up as a supervised learning model. So basically we have covered almost all topics. Just okay, so this is still training. In the meanwhile, we can use the previous feature. So I'll say hi. I'll just repeat hi. It gives a reply hi. I can give another hello. It gives me a reply. How can I help you? I want to order. It will ask me, what do you want to order? So no one has told it I actually mean I want to order. It has understood Order means maybe it is the intent of ORDER, and ORDER dialog will be what do you want to order. I'll say a pizza and a burger. Okay, so now this is not a child node, so that is the reason this has happened. Okay, so burger intent or entity has not been understood. That is because the burger thing is a child node of order. So I need to again say I want to order. Okay, then say burger. That is when it is going to add into the cart. And again coming back to that concept that I was telling in the beginning, your user interface and all the front end part have to be managed separately. So this is not going to remember what you have in your cart. So this is purely the AI conversational part. So this is going to give a prompt to whatever, maybe PHP or HTML that you are coding, or Python, that is going to set a variable saying cart, and there it says you have customer one has ordered one pizza, two burgers, three cokes. That is where it's going to store. So here it will not know how many pizzas are there in my cart, how many burgers are there in my cart. So this is purely the conversation part. And then say, can I pay? So it says, how would you like to pay? So that is where our model is actually ending, because I have not given it anything further. Okay, I can go back to entities now, create an entity, say card. Okay, debit card. Okay, so basically I'm giving in a payment method now. Okay, so that it can understand the entity. Okay, okay, so I have given three values of card. I come back to dialog and create a node for, okay, I have to create a child node now. Okay, I have to create child node of the payment uh, node. Okay, so here if the Watson recognizes card entity, okay, if the person says I want to give card, then say please give card, or please swipe your card. Okay, so these things are told. Okay, so it's another sub node that I have added for user pay intent. Okay, so again this is training. So if I say I want to pay, it will ask me how would you like to pay, how would you pay. If I say card now, it will not understand. Can you reword? Okay, but let us just wait for the training to complete. Yeah, so training is done. I just say I pay, how would you like to pay. Now I say card, now it says please give card. Okay, now here it says irrelevant. Okay, that is because that is the intent. So there is no intent that has been there is no intent that has been recognized. So just now I selected it, but if you just saw, it was irrelevant that was there. So here you can see card irrelevant, because card there is no intent associated with card. Card is an entity. Okay, entities come here at the bottom in the blue color and at the rate. Okay, so yeah, that completes our model. After this, you can go back to this assistant thing. Okay, and here you're going to use your or rather here, yeah, here you can take the API and refer it to this particular skill, this particular assistant, and write a program to input data and get an output out of it. So that is how the assistant complete thing happens. Okay, so whatever happens here, whatever inputs and output happen, same thing can be done through a application program where you're trying to import this. Yeah, so any of you have doubt in this, or I guess we can that completes our session for today. Okay, then maybe we can wrap it here for today, ma'am. I'm done. Hello. Hello.
Hello.
Yes. Yes, ma'am.
Yeah, yeah. Sorry, I had some vocal issues. Sorry. So that was
Yeah.
really wonderful. Are you completed with the session, Abhinav?
Yeah. Yeah. I'm done with
Yeah.
the session.
Thank you so much, Abhinav. That session was really wonderful because I was a person who was not that much interested in AI, but after listening to your session, your teaching skills are really good. This is really appreciable at your age. You have been doing so many wonderful things, and we hope you have a very nice relations with us. And thank you once again. And there's a poll, guys. Everybody do attend the poll. Please submit your poll and you can leave the meeting. Thank you so much, Abhinav, once again.
Yeah. Yeah. Thank you. Thank you very much, ma'am. Thank you very much, everybody. Yeah, you guys can connect to me on Instagram or LinkedIn for in case you have want any help or you have any doubts regarding whatever we have done as of yesterday's and today's session. Okay, maybe the team at the Tech Vision can help.
Yeah,
Okay,
yeah, we'll
yeah,
do share your profile on. Yeah.
yeah, okay, okay. Yeah,
And guys, do follow Technician Club also. We'll be updating about all our meetings and things. So you can get any updates from our Instagram profile. And we would also share. Thank you, Abhinav, once again for this wonderful session.
yeah, yeah. Thank you. Bye.